Okay, so guys, this is 13.5. We are going to take a step away from the unit circle, which I know some of you will love, and we're going to take a couple other formulas that help us solve triangles when we don't know enough information about them. Well, specifically when these are not right triangles. Because we don't have right angles, the traditional trig functions don't work, but there is something called the law of sines that helps us understand a lot about the stuff. And it is basically that the sine of an angle divided by its opposite side is proportional to the sine of any other angle divided by, or is equal to, any other angle, sine of angle divided by the opposite side. So think of A, B, and C as angles in the triangle, and as little a, little b, and little c as the sides that are opposite. So if I'm thinking about a little triangle A, B, C, little a would have to be here, little c, little b, because they are directly across the triangle from one another. Well, the same is true if I flip the fractions upside down. We're just saying that there's a relationship that's true for all angles and their opposite sides. That there's the bigger the angle, the bigger the opposite side. And that's sort of the relationship that we see here. So the smaller angle, smaller little guy, smaller side means a smaller angle, and so on. So we're going to use these three things to help us solve our problems. But we're not going to use all three of them at the same time. We'll probably just pick two of the fractions and solve using those two fractions. These equations are essentially the same. The only difference is on the top here we have angles, on the top here we have sides. You always want to use the version that allows you to find what you're looking for on the top. It makes the multiplication and the arithmetic much easier. So going and looking at a problem, number 4, we're being asked how many triangles this would produce and whether there's one triangle or no triangles. The way that we check is by, well, finding the A, B, and C. Let's just real quickly run through. Obviously, capital B is the missing angle here. And since we have 40 and 75, if we take those away from 180, we get 65 degrees. So, okay. Now the question is it possible to use this? If it is, we're going to have a triangle that works for us. And so we're just going to throw these things into the law of sines. I'm going to be looking for little b and little a. So I want those to be on top. So let's say little b over the sine of big B, 65, equals 20 over the sine of 75. And if I were to solve this for b, I'd multiply by the sine of 65. And I will get a value for b. I don't see anything in here that makes me think this won't work. 20 times the sine of 65 divided by the sine of 75 comes out to be about 18.8. And that's just fine. It's smaller than that. I don't see any reason why this wouldn't work. A over the sine of 40 would equal 20 over the sine of 75. I'm going to multiply by the sine of 40 to get rid of the denominator over here. And so again, I'd have 20 times the sine of 40 divided by the sine of 75. It equals about 13.3. I did not run into anything that scares me. These are all just numbers. It all works out. So I'm going to say that there is one triangle that this forms. It is possible to have it form more than one triangle or no triangles. But this seemed to work out. I didn't seem to have any issues or hesitations. So I'm going to say that there's a triangle there. One triangle. As we move on to number 12, we're being asked to solve the triangle. I think this is my A, B, and and C. So the things I'm looking for are capital A. I have little a, but I'm also looking for little b and little c. So the first thing is to find capital A. I can take 85 and 47 and subtract those from 180 to get a 48-degree angle. And I'm part of the way there already. Okay? Well, now I need to use the law of sines to find little c and little b. I'm doing this because there is no right angle, and so there's no hypotenuse here, there's none of that, so I have to deal with what I have. Well, I'm looking for, say, c. So little c over the sine of 47, that's its partner, it's big angle, should be equal to 19 over the sine of 48. Of course, I'm going to multiply by the sine of 47 times the sine of 47. And c is going to equal 19 times the sine of 47 divided by the sine of 48 is 18.7. So there's two pieces of information so far. I still need to find little b, which is little b over the sine of 85 is equal to 19 over the sine of 48. Again, times the sine of 85. And b equals 19 times the sine of 85 divided by the sine of 48. Comes out to be 25.5. And if you think about it, B is the biggest angle, so it should have the longest side. Makes sense. And so that's what we'll do to solve triangles. On 24, we get there and it asks us to solve the triangle. But they also tell us that some are going to have no solution or no triangles formed by them. This is going to be a no triangle. And here's how I can tell. 98 is an obtuse angle. That means that C really does have to be the biggest side. But C is 29 and A is 33. There's no way this is going to work. But to confirm it, to show you what it would look like when no triangle can be formed, we're going to start with this. We're going to say the sine of A over 33 equals the sine of 98 over 29. I'm actually going to grab my calculator to do this. Oops, got the wrong one. Alright, I'm going to grab my calculator, keep it handy, clear this out. I'm going to make sure that I'm in degree mode, which I am. And I'll take the sine of 98. I'm going to divide that by 29. Okay? And then to move this over, I'd just be multiplying by 33 times 33. Okay? 1.13. So the sine of A equals 1.13. Well, now I need to get rid of the sine, so I have A by itself. So I'll use sine inverse. And A equals, let's find out. Grab that calculator back out. We're going to take sine inverse of our answer. And we hit enter. And it says there's a domain error. That answer was 1.13. Remember when we looked at the unit circle last week and we said that the inverse can never take the inverse of something bigger than 1? Because this would mean that one of the sides of the triangle would be bigger than the hypotenuse or bigger than the biggest side. Yeah, this doesn't work. So there's no triangle that can be formed from this information. There's no way to use those three measurements to get a triangle. So anytime you try to take the sine inverse of something and it's bigger than 1 or less than -1, that means you're going to have a problem. Okay. Then we want to talk about how do we find the area of a triangle when we can't easily measure the height. Well, there are three formulas, and they are all the same. Just rearranging the letters. It will be 1/2 AB times the sine of C, or 1/2 AC times the sine of B, or 1/2 BC times the sine of A. Any one of those works as a formula. Just have to figure out which ones we have. Take the letters the sides that you know, multiply, and multiply by the sine of the other angle. It's an interesting way of working itself out, but really what it's doing is cutting the triangle into right triangles, which we can find the area of pretty easily. So here I have capital C is 79, little a is 25, and little b is 17. I'm going to use the formula that area of the triangle equals 1/2 little a, little b, times the sine of capital C. I'm just going to plug it in. 1/2 times 25 times 17 times the sine of 79, and again I'm in degree mode here, so my area equals, and I'll just grab my calculator and plug it in. Clear that out and say that I have 0.5 times 25 times 17 times the sine of 79, close parentheses, enter. An area of 208.6, so 208.6. In the textbook, they really don't tell me any units, so I'm just going to put u squared, units squared. You could use inches or feet or whatever measurement you'd like, but it's in units squared. That's what you're going to be asked to do. Again, it's application of the law of sines, which I would memorize at least one of the two versions, and then the formulas for the area, very important. Remember, if you're getting errors on your calculator, it means that there's no such triangle. So good luck and have a good week.